Hi guys, just going to run through a quick example with confidence intervals. This question was taken from tutorial 5 week 6, question number 4a. Construct a 90% confidence interval where the sample mean is 36, the sample size is 16, and the sum of squared deviations from the sample mean has been calculated as being 255. So let's first take the data from the question. So sample size 16, sample mean 36, sum squared is 255. Now we don't have the standard deviation of the population, so we're going to have to estimate that using the formula that contains SS. So estimated population standard deviation is equal to the root of the sum of squared deviations over the degrees of freedom. And now the degrees of freedom, that's just equal to the sample size minus 1, which is here. So calculating that, that's root 255 over 15, root 17, 4.123. Now from here, we want to find the estimated standard error mean, because that's what we'll need to calculate our confidence interval. So the estimated standard error mean is the estimated population standard deviation over root n, and root n is 4, gives us this. From here we can start to calculate our confidence intervals. So we're looking at a 90% confidence interval here, and that corresponds to an alpha value of 0.010. We need to know that number when we're looking at our data tables. Also, since we're estimating our values here, we'll be using t tables instead of z tables, because we're using t-tests. So you're using a t-test, two directional, because obviously it's a confidence interval, so there'll be part of the critical values will occur at both ends, and alpha equals 0.010. And now, if we take a look at our tables here, t-test, t-distribution, two-tailed, alpha equals 0.010 and n equals 16, gives us a value of 1.75. That's t-crit. And now we want to calculate our lower bound and upper bounds of our confidence interval. So, lower bound, that will be equal to the formula. That can be solved using the formula sample mean minus t critical times the estimated sample standard deviation. Just plugging in the values, 34.2, and then the upper bound is calculated in the same way, but this time we're adding the critical value times the sample standard error mean. And that's what gives us our confidence interval. Hope that helped.